Okay, so in this video, we're looking at Module 2, which is Networks and Decision Mathematics from the Exam 1 of the 2018 Further Maths exam for NHT. All right, question 1, consider following graph. Which of the following statements is not true for this graph? So if we look at this graph, we can see, let's have a look. Let's see what, in this case, what have we got? Which one of the following is not true? So how many vertices does it have? It has 1, 2, 3, 4, 5, 6, 7. All right, we know that that answer is wrong because there are 7 vertices. There are no isolated vertices. There's nothing isolated there. Do all the vertices have an even degree? Well, let's check. 2, 2, 2, 4, 2, 2, 2. Well, I mean, they're all even, so therefore this answer is wrong. 6 of the vertices have the same degree. Well, we've got 6, 2, so again, that one's correct, but therefore it's not right for this answer. What's not true, if we sum all those up, we've got 6 from here, 6 from here, so that's 12 plus 4 would be 16. So our answer is E. All right. A puzzle has 4 parts. These 4 friends are solving a puzzle together. The table below shows the time it takes each person to complete each part of the puzzle in minutes. Okay. The parts of the puzzle must be solved one after the other, with each friend completing one part. The minimum time taken to complete the entire puzzle in minutes is, well, this is where we have to do it at a Hungarian algorithm approach. Okay. Now, first off, you do a row reduction. So if I do a row reduction, I'm looking on the top line, I'm looking for my small sum, and the small sum is 5. So I'm going to go 0, 0, 0, 0. Row reduction on the second row, my lowest number is 3, so I'm going to go 0, 1, 2, 3. Row reduction on the next one, smallest number is 3 again, so I get 3, 2, 1, 0, and we can see that's all going to be zeros. All right. So what we've got to look at here is, the best way to do it is, can you sort of highlight each line? We've got 4 by 4, so we'd have to have used 4 lines to cover each of the zeros. So if I went like that, if I took 3 lines, I can't do this. But how many lines do I need? But I want the minimum, so I've got another line there. I've covered that, and I've covered those. Okay. So at the moment, after a row reduction, and let's be honest, it's not usually after a row reduction, but after a row reduction here, I can actually solve this question. Okay, let's pick a different color for this part. All right, so I need to highlight the spot where I can assign my basically assign my zeros. So if I look at this, it is a bit harder to do here. So maybe what I'll do is I'll do a quick 0, 0, 3, 0, 0, 1, 2, 0, 0, 2, 1, 0, 0, 3, 0, 0. Okay, so when I look at this, so if you look at this, we've got the 0 here, so we've got a bunch of zeros so we can pick. So let's pick, well, Bruce can do part 1, in this case, part 1. Okay, that would mean if Bruce is doing part 1, that means Christy's doing part 4. And therefore, you could pick either one of those, to be honest. And for Audrey and Darren, if Audrey did part 3, then Darren would have to do part 2. And to be honest, it doesn't really matter in this case because you could flip around there. So what that means is the numbers I'm looking for are the 3, the 5, the 5, and the 3. So that's 8 plus 8, so 16. So the answer in this case would be B. Often they're a little bit harder, but that one's tricky because he's expected to be a bit different there. So question 3. The graph has 6 vertices and 7 edges as shown in the diagram below. For the graph shown below, is it possible to find a bunch of these. So an Eulerian trail on Eulerian circuit, etc., etc. I'm not going to try to say all those words together. So let's have a look at what we've got in terms of vertices. So I've got 2 here, I've got 2, I've got 4, I've got 1, I've got 3, and I have 2. Okay, so we know from our rules that we can have an Eulerian trail if we have 2 odd vertices and the rest are even, and we do have that. So that means it can't be a circuit because they all have to be even. So therefore, I can get rid of these 2 down here. All right, and so we have a look if we've got in this case, do we have an Eulerian circuit? As we said, we can't have that. So that means in this case, A is also out. Because this bit here, I missed that bit just before. So it comes down, does it have a Hamiltonian path of cycle? So remember, Hamiltonian means it's touching each of the vertices. So if I look at this, can I, without repeating, so I can go here. So I can't get back to F without touching other vertices. I only want to touch those vertices once. So therefore, I can't have a Hamiltonian cycle, but I can have a Hamiltonian path. So there's question 3. Okay, question 4. Network below shows a sequence of activities required to complete the project. We've got the names there of an activity shown. The project is to complete in the minimum time possible. The activity has a latest starting time of 12 hours. Is completed by. So let's have a look. So this is going to come up here 3, 8, and then coming into here. So for Iggy, it's going to be 11, 15. What about this one here? So Bob's going to be 3. I normally would do it differently like this, but I'm just sort of getting the key points here. 10. So coming in here for Jen, I'll have 15 again. No, I can't count, can I? Because that's not 15. That's 18. Oops. No, it's 15. What am I doing? Oh, that was a bit of a brain fade there. 8 plus 4 is 12. That's 15. That was a bit of a brain fade on my part. My apologies. 3 to Fab, that would be 8, and 4 would be 12 again. So Kai, coming in from Kai, would be 12. Cal would be 6. That would be, Hal would finish up at 8. So Mo would be 20. Would be 20. This would cross the Gok would be 7. 7 and 3 would be 10. So Lee would be 10. Okay. So the activity that has a latest starting time of 12 hours completed by, in this case, sorry, I had yet another brain fade then. So hopefully you picked it up and you thought, what is this guy doing? This Mo, 6 plus 2 is 8. 8 plus 6 is 14. Not great. But we'll move on. So that means so you're finishing at 15. All right. And so normally you'd go back and you're looking for the highest number. So you're going to go 15 minus 4 is 11. It's not going to be that because this is the one that's the latest start time. 15 minus 5 would be 10. It's not going to be that. It's not going to be that. 15 minus 4 is going to be 11. It's not going to be that. 15 minus 3 is going to be 12. It's looking like that. 15 minus 6 is going to be 11. Not that. So therefore it's Lee. So we're going to circle D for Lee. The friendships between 5 children are summarized in this graph below. Okay. The vertices of this in each graph represent these children. Each edge between 2 vertices indicates that 2 children are friends. So B and C, if we went to B and C, shows that child B and C are friends. So we make an adjacency matrix. Summarize of friendships can be constructed. In this matrix, a 0 indicates no friendship and 1 indicates a friendship. How many 0 elements would this adjacency matrix have? So let's do this adjacency matrix and then we'll calculate the zeros. So I'm going to put A, B, C, D, E, A, B, C, D, E. Okay, so A to A, is there any A to A's? No, there's not. A to B, there's A to B, there's 1. There's also a B to A, so I'm going to put a 1 there. A to C, there's no A to C, so there's going to be 0 there. So is there any C to A's? There's no C to A, so let's go 0. A to D, I hate when it does that. A to D, yes, we've got one here. Okay, so A to D would be 1. So therefore, D to A is going to be 1. I should be doing it the other way around, but I think you know what I mean. E, in this case, because I'm going across like that. So A to E would be 0, and E to A would be 0. All right, I think you got the idea there. I'm just going to fill it in. Okay, so I can sort of, this video doesn't take too long for you. And 0, 1, 0. Make sure when you do this that what you get is the same as what I get. Sorry, I think you just heard the sound of my phone ring. All right, so now I go the rest of them. I'll finish these off. 1, 0, 1, 0. And all you need to do is essentially highlight the zeros there because that's what it asked for. How many 0 elements? It's easy just to highlight. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so, do we have 11 there? And so we circle E. All right, so we're up to question 6. So question 6 is a minimal spanning tree is drawn for the weighted graph below. How many edges with weight 2 will not be included in the minimal spanning tree? Okay, so I'll just use a highlighter or something to highlight things. So I'm going to initially highlight my 1s because they're my lowest value. So they're going to be in terms of the minimal spanning tree. Okay. I'm going to connect up some 2s here. Okay, so they're connecting my dots. So far, that means I've already identified a 2 that I don't need to use. Okay, if I can get from here to, so it's looking like I don't need to use that 4, so I can go up to here and I can do something like that. That means I've already got a second 2. Okay, so I don't have to do 6. Highlight again. I need to go there and I need to go there. Guess what? That's another 2. And I've only got one more line to use. And to be honest, it could be any of these 3. So I'm just going to pick that one. Doesn't really matter which. So that means I've got another 2 left over. So I'm going to have, in this case, 5 2s. And that's our answer for this one. A simple connected graph has at least one vertex with an odd degree and at least one vertex with an even degree. Okay, which one of the following could be the number of vertices with an odd degree in this graph? Okay, so this is one of those questions where I know when I first tried this one, it got me a little bit because I just couldn't grasp what the question was asking. It's not hard. It's just for whatever reason I couldn't get it. So it's got at least one vertex. One vertex has to have an odd degree, and at least one vertex has to have even degree, and that's crucially important. Because if I draw it, I'm going to draw one. I'm going to draw this and this. That means I've got 1 degree, 2 degrees, 1 degree. Okay, it's fit that. So how many odd vertices with odd numbers do I have? I have 2. Let's try another one. So got 1 degree there. Got 2. Got 2. And I've got 1 again. Okay. So I still follow my thing. I've got 2. You could have something. So let's see if this one works. So I've got 1, 3, 2, 2 again. Okay. I've got an even number. So it's hard to, the number of vertices with an odd degree. So the number of vertices in this case, the number of vertices has to be an even number. Okay. So, because I'm getting 2, I mean, you could do more, but that's how I was working that. So therefore that answer is going to be B. So each time you do something like that, and with following the restrictions that are placed upon from here, you're going to get an even set of odd vertices, odd degree vertices. Okay. All right. An object consists of 8 activities. The table below shows the immediate predecessor and earliest start time in hours of each activity. It is known that activity G has a completion time of 3 hours. It can still be completed in the minimum time if activity C is delayed. The maximum length of the delay for activity C is, and so what we're going to need to do here is draw up what's happening. So I'm going to start off with a point here, and I'm going to go like this, and this is my A. Let's put a 4 because it said, all right, this one, I'm getting ahead of myself, sorry. Oops, way a bit ahead of myself there. All right, A, let's start that again. Activity A starts there, and it's going to, so I've got C, that's my predecessor. So C needs to start with A. I've got B. B needs to start with, no, I'm actually going to draw it like that. Sorry, I actually like putting it there. So that's activity C there, and that's going to be activity D, okay, because activity D comes off B. All right, so at the moment we're on to E comes after C, so let's put activity E. All right, D, is there anything coming after D? D, well, F. So I'm going to have F. Where does F come? F comes after H. So let's put and it's got F and a G there. So therefore my D, oops, imagine that's a straight line. Let's do that again. That's going to be, in this case, it's going to be F. Okay. And E. And then in this case, we're going to have G, and then we'll have H out here. Okay. All right. So what we're looking at here is, so early start time for C. Oops. is going to be 4 because we're told that. Early start time for D is going to be 12. Okay. Early start time for E, 15. Early start time for F, 19. Early start time for G is 27. And an early start time for H is going to be 36. Okay. So what we've got to work our way back with here is, so in this one, to keep in mind, we're told this, and I actually nearly forgot it, to be honest. G has a completion time of 3 hours. So that's our 3. And we're looking for the C part here. So we can ignore the bottom part, but you need to draw it out to start with. So 36 minus 3 will give you 33. Okay? Now, we know that based on the early start time, 15 to 27 is 12. So we know that that is 12 there. So 33 minus 12 will be 21. We know that this C is 11, okay? Because between 15 and 4 is 11. So 21 minus 11 is 10. So how long can C be delayed before it starts? That's my float time there. So my float time here is 6 hours, okay? And so that, and that's question 8, that is the end of networks questions for this, okay? Thank you.